Hi, welcome to another video in this series. In the last video, we went over application and host hardening techniques. On this video, we're going to go over incident response tools. And in the first exercise, we're going to be configuring system logging. So just while everything is loading here, so system logging protocol, right? It's a protocol responsible for sending events for one or more systems to a single server. Trying to get my mouse to work here. But there are three components, right? So there is a system syslog forwarder, right? Then you have syslog connector, and then you also have syslog analysis, right? And so particularly syslog daemon, right? It's let's get this here, right? It's a program used for administering and managing a system security. Okay. All right, perfect. And this should work. And analyze so it's good for administrating and managing a system security and analyze debugging messages. So make sure. All right. So all the hardware devices, they run their syslog daemons. Huh. Okay. All right, perfect. So what we're going to do first is view the syslog daemon configuration, at least for first within Kali Linux. So a system needs to maintain the log files, right? So the core intent of maintaining log files is just to track messages, but about various system components like the kernel, CPU, security, applications, things of that nature, and different log files can contain different sets of messages, which could be varieties like error or system information, and the system administrator can use these logs to manage the system. So what we're going to do is actually run a few commands that we'll be taking a look at the log files. So we'll first use this one here. It's for me. All right, yeah, this lab has been, you're right. So each line, right, that I type for the command, it has three directives. So it has the facility, the level, and the action, right? So the facility is for the message creator, for example, the security or the kernel. And the level is for the severity level naturally, and the action is the destination for the log messages, right? As far as the how they're addressed. So now we're just right here, we're just viewing the contents of the configuration file that I've commanded. So let's actually clear this out like a clean window. So now we're just going to view the loaded modules. So we'll do this here, right? And then we'll do the same. All right. Perfect. So no lines contains the word mod load, right? So therefore no response is returned. So now we're just going to check for global directives. So to check for a global directive marked with the $sign, we'll use this here. All right, perfect. So we can actually get to the global directives here. There it is. This is our global directives section, and there are multiple global directives, right? We can actually similarly look for rules, etc. in this file as well. So now that we see the directives, I'm just going to close this out, right? And get a clear window. And now the syslog service comprises of two services or two key processors. So rsyslog and klog, right? And so the rsyslog, the process is responsible for logging events from user processes. So we're just going to make sure that both the processes are running, right? And I want to do that with this command here. Perfect. So now I see the status of both processes, right? There. So now we're just going to take a look at the configuration of log rotate. So the log file by default, they are contained in the VAR log directory. So the directory contains various types of logs like the boot.log, cron, yum.log, and logs can go to master sizes, right? It may become too difficult to manage. So to resolve this problem, the log rotate daemon is used. So the log rotate daemon just the suffix is the current message file within today's state, and a new log file is usually created the next day. So just going to carry out the configuration of the log rotate in Linux. So we're going to use this. Perfect. All right. So now we see some files that are marked with older dates, right? See them here, right? Now that we see that, we're just going to clear this out. So now the log rotate, it naturally uses the configuration defined in the etc log rotate.configuration file. So I'm just going to take a look at it, right? Perfect. All right, so now I can see, right, what the file contains, right, as far as a few key parameters, like when to create, what to do after rotating old log files in the naming convention, a rotated log file. So now I can see that. I'm just going to clear this out. Now, log rotate uses two key files, right? USR SBin, which I've done in another video. This is the log rotate command, and then you have etc cron, right? So now I'm just going to take a look at the etc cron daily shell script. I'm actually going to use this command, right, to take a look. Perfect. All right, so now just going to clear this out now that I can see that, see what I'm taking a look at. So now the etc log rotate, that file contains the log rotation information for the packages. So this means that when you install a package in Linux, the log rotation information, it'll be collected in the directory, right? So for example, you could view the log rotation, all right, for, let's see, on the Samba package. So we're actually going to take a look at that. Perfect. All right, so we can actually take a look at all of these logs, right, specifically to the Samba package. So, and viewing the log package configuration file just gives an administrator an overview of viewing the specific activity, right, that will be logged for the specific package, so the file can actually be modified depending on the specific logging. Depending on the specific log requirements for the package. So I'm actually just clearing it out. So now when you run the log rotate command, you can actually write the status with the help of the -s parameter, which is here, right? Okay, perfect. So now just running the log rotate command. With that command, so log rotate messages, they are written to the VAR log status file. So whenever we need to run the log rotation for specific files, we'll need to prepare the log rotation configuration and manually run the log rotate command. We can also add customized messages into a system log using the logger utility. So we can actually use that with this command as well. So bear with me a second. All right, perfect. Now, you can use the man logger command also to get more help on this particular command. And what happens is this will log error message to this particular file, mail.err, right, with the process ID and the user account and the timestamp for the error message as well. But actually, let me clear this out. So I know this is going to log the system reboot, right? So, right, perfect. All right, so now the syslog command is now replaced, right, with the journal command, which stores similar information to syslog. So just going to write this command here. Right, just to view the journal deconfiguration file, right? And we see the list of everything here, right? Now we can run the journal, right, CTL command to get messages from the VAR log directory. And by default, the journal CTL command provides unfiltered messages, but we can use various filter to filter messages, right? This is just one of them. And I can actually keep pressing enter to display subsequent logs, right? Just keep doing it. Now, the journalctl command is actually used on a Linux system to display the collected syslogs. So these logs will actually be used to review the event that occurred on the system. So now I'm just going to leave out of here, quit the display so I can reach back to the command prompt. Then I'm just going to clear it out because I, again, like a clean, very clean window. All right, so now I'm just going to view the boot messages logs with this command, right? And again, same concept. I could keep pressing enter to view the subsequent log, right? Just keep over and over again, right? And then of course I just Q, I quit. I didn't even have to enter. Once I hit Q, it'll automatically get me out of there. So I'll just do that, clear it out so we get a clean window. Now we're just going to view the logs filtered based on priority with the journal. There we go. All right, so now the -p crit parameter is just going to filter the log based on the critical priority. So the logs are filtered based on just that. And so there are no critical entries. So just going to quit out of here, right? Because there are none, so none are going to generate. Now the journalctl command with the specific parameters, right? They display critical events that have occurred on the system and can be used by administrator to remediate any issues. So now I'm just going to view them by timestamp, actually. So let's see. Perfect. So I can also do the same thing, same concept. I could keep pressing enter to display subsequent logs since May of 2020, right? Perfect. Now the log files for specific dates, specific start date usually can be displayed. So an administrator can actually display log files for a specific time period for investigative purposes. So we can actually check boot events right in the log file. So just like in a Windows system, a Linux system also generates log files as well. So we can actually take a look into that. So we can actually clear this out, and now we can just take a look one more time at the boot event. Let's see, pressing enter. I just like doing it. So you see all the boot events on the system, and again, it can be used by an admin to identify any possible security events. So we're just going to exit out of there and clear up our windows. Now we're just going to view details for that were logged for the boot events, right? All right, perfect. Actually, let's see. There we go. All right, perfect. Good. All right. All right, so now I just want to view the details, right, of a specific boot log with the journalctl. I'm just going to highlight one of the lines here. Let's do this one. Yeah, that's what we want to do. All right, perfect. So I'm just going to exit out of here. So now I'm just going to view the log file for the selected event type. Let's see. So I'll actually place the last command, but I'll do, darn it. Oops, equal. And so I just all have to do this. Perfect. All right. So it just now that I pasted what I had as far as one of the log events, it allowed me to see a bit the information a bit differently specific to that event, right? So for that particular boot event, rather. So this could be again used to investigate any possible security event. So we're just going to exit out of that, and we're going to clear up our window. There we go. All right. So now we're just going to view the event in the kernel log. So let's do this here. Okay. I can't spell, right? All right, perfect. So now we're just going to view the events from the kernel, right? So now it just displays also the boot events specifically related to the system. So this is just a global overview of the occurrences on the system. So just going to clear it up here. So we can also view the DMSG log to obtain information about the system hardware, and it can be useful when we're trying to troubleshoot a system hardware. So we can actually do it this way. We can take a look here. Executing the command. And again, an admin could use this command to troubleshoot specific hardware related issues. So to find out the amount of physical memory in the system, right, we can actually type this command here. Right? Perfect. I love it. I love when everything goes smooth, don't you? So so now we're seeing or we can see the amount of physical memory in a particular system, right? So and that allows us to get to our next exercise, which is going to be using tcpdump and log. So tcpdump, we went over this in multiple videos. It could be used for packet analysis. I'm not going to get too much into it since I've already done that in other videos. So I'm actually going to close this out and reopen a brand new one. So let's do that here. All right, perfect. So using the tcpdump command, we can actually capture packets like we did before using a specific interface. So, excuse me. So just gonna, for example, right, if the system has a ETH0 interface or ETH0, rather it's the interface, you can use it for capturing packets. So, and when I use the I parameter for specifying the interface, so after the command is starts running, right, is sometimes it could take a few minutes for us to receive a reply. And this type of command will actually keep running until I break it, pressing the Control C. But nonetheless, I'll just clear it out. And instead of running the command continuously, I'm just going to run it for a specific number of times. So just going to do, let's see, there we go. Perfect. All right, so, and as you can see, the C parameter or the subtract C parameter is just used for specifying the packet count. So it's just, they're just showing the output for a certain amount of time, but nonetheless, we're going to stop it just for the purpose of continuing on with the exercise. I'm just going to clear out the window. We can also list available interfaces in our system with tcpdump with this here, right? Perfect. So now we see the list of available interfaces displayed, right? And I apologize if I'm going a bit too fast. Video, sometimes with a lot of exercises like these, they can get quite extensive. So I'd like to try to remain at a reasonable pace, but not too slow at the same time, just so I can get through everything I want to cover in the video. But we can also save the output, right, of the tcpdump command, right, as well with this command, this practice lab, right? So let's see. All right, perfect. There we go. I can actually let this keep running. It's just going to run continuously like before until I break it with the Control C output or the keys on my computer. So after I sent the output to a file, I'm just going to read it with the -R. Let's see. All right, perfect. So now we can see, right, the output from the file that's displayed, right? So going to clear now, rather than using a specific interface, you can actually capture packets using all available interfaces, right? And you can actually do it with this, simple as that, right? And it's going to keep running, right? Going to keep running until you tell it to stop. Until you tell it to stop, right? And just run one more, a little more. No? Oh, there it is. All right, that's enough. Now, by default, tcpdump actually can capture all types of packets, but we can limit it to capture only a specific type of protocol packets, right? So let's see, ICMP, which is fine. All right, and actually, I'm going to open up a new window. You can still see the window behind it. Yeah, that's fine, I guess. All right, so now I'm just going to ping another server that's on the Lisa Practice Lab network. Okay. Now, as you can see, it's capturing. All right. Let me actually put this in the forefront. All right, see if I could put these next to each other. All right, so now we can move forward with our next task. It's going to be knowing the key locations for logging. So logs are meant for recorded events in the system, right? So what we're going to do now is test the Apache web server traffic. So we're actually going to open a new terminal. Um, let's see here. So let's first list the number of logs in the var log directory. So we're just going to do that with this here, all right? So we see all the number of logs, right? All right. So now that we see that, we can actually clear this out. So to view a log file, we can actually still go back to the cat command, the concatenate command that we actually um, used before. All right, perfect. Love it. All right, perfect. So now we're just taking a look at the log file, right? We can see everything that's going on. Oh, okay, I thought my system was going to go down for a second. But nonetheless, that is how we view a log file through that sense, right? As far as that exercise goes. Now we can move on to our next exercise. It's going to be capturing packets with Wireshark, which we again done another video, multiple videos with capturing packets. Definitely something I want to reiterate as much as possible as a cyber professional, especially an entry level cyber professional, being able to just get a feel of the landscape, get a feel of different GUIs, not just Wireshark, even though it's one of the more prominent ones in the lab videos I'm doing, but just to get a better feel of how everything works out as far as capturing packets in general, right? So what we're going to do first is capture some traffic information. So initially, we're going to be using Wireshark, right, to view the information from the device on the network. But when we select an interface such as like Ethernet or Etho, Wireshark, it'll activate the capture the packets instantly. But we can also filter it as well. Okay, let's see. Let's actually start here. So now we started the packet capturing process. You can see from this status has changed. This is highlighted blue when there's nothing being done, and we have the red highlighted just for when we need to stop. So in order to have it capture something, as you can see, there's nothing going on. Just going to open this puppy up here, the server. May have to reboot it for it to actually capture anything though. Not sure yet. Let's see. Yeah, I'm gonna have to reboot it. So let's see. There it is. All right, perfect. So now we can see the packet capturing, right? Now that the Win10 is booting up. So we can also see the ARP data and the TCP traffic, right? We want to look for the ARP request when Win10 actually starts. So bear in mind that the IP for this address, I'll have to actually look for that address, right? So let me actually make this a bit bigger. So once it's successfully restarted, which it hasn't, it was supposed to, I'm going to actually end the capture packet process in Wireshark once it's fully up and running. And yep, that should be good. And perfect. All right, so I'm actually just going to filter for ARP. Perfect. Now we see the protocol, right? So we see several ARP packets have been captured, right? Okay. So we can actually, I'm going to click this out now that we've located that. Now we're just going to analyze the captured information. So we can actually list information according to different tabs, right? So then we can move them to basic filtering techniques. So just knowledge of protocols, right? As I mentioned, just getting more and more reps, right? With again, I use Wireshark a considerable amount, but again, this is just in general packet capturing. I've also done it with other methods as well, but want to just get my hands on it as much as possible. So we start capturing packets using Wireshark and may capture like thousands of packets within a few minutes, right? Depending on your enterprise naturally in the network. But it's not easy to analyze thousands, right? So that's why you want to use the easiest and efficient method as much as possible when it comes to filtering. So, which is a feature provided by Wireshark, and the DUI isn't bad either. So I'm actually, let's take a look at a few options that we actually have in Wireshark. If my mouse wants to work, there it is. All right, it keeps going in and out because it's a Bluetooth mouse, but nonetheless, you guys don't need to know that. So, so we can actually scroll through here. We can find some details about the ARP sessions, right? Actually, I can do that. So perfect. We can actually find some more details, right? We see a device establishing their address, right? So, for example, this IP, right, for ending in 03 for the Win10 system just confirms its address location, right? Um, yeah, just not agreeing with me at the moment. So, so actually, let's see. Let's actually um, make this a bit bigger. We're not looking at the details here. All right, so pre-request. There we go. So we found Win10. I just wanted to see the device of the Win10. And we can see that if you want to take a look, so we see here, right, that it has a gratuitous request via a broadcast, right? So effectively setting a source and destination address against its IP. So if another machine did own 0.3, Win10 would just duplicate the IP address and then promptly use it and just change the configuration. But Wireshark could just decode the OUI, right? And now we can expand actually a few things like the MAC fields to decode the multicast broadcast bit and locally administered bit, right? So I'm actually going to take a look for that. So perfect. So we can actually view all the traffic that's flowed from DMO1 since the recording began. But it looks like it looked like there was none. Oh man. Oh man. Yeah. Oh well, that's fine. But you guys get the point, right? So I'll just X this out. So now we're just going to take a look at displaying a capture information with the Wireshark in particular, right? So we all know that it captured many packets from the network. Therefore, all this information is difficult to parse through, right? And interpret everything. So it's not the only tool for capturing network packets. Tools like tcpdump, WinDump also perform the same function. However, Wireshark has the capability to open the files that have been saved in tcpdump and WinDump, right? So we can actually explore the capture packets that we've seen in various tools that are provided within Wireshark. So I'm actually going to take a look at a few things. So let's take a look at, let's see, statistics. Take a look at the resolved addresses, right? So we can see resolved addresses, where they were found, the comment, where they came from. We see Win10, right? TCP ports, different objectives. Oh, man, like pretty much a lot of different stuff, right? All right, so actually let me exit out of here so I can take a look at some other stuff. So we actually can take a look at the IO graph. Actually, you know what? Let's take a look at protocol hierarchy. Let's go on the road. All right. Or you know what? Let's actually saw something else I thought. It's gonna come up. Let's take a look at conversations. Take a look at the UDP here. Okay. All right. So the UDP8, whether it's not being used at network devices, you're just going to continue to communicate with the other devices. So it's not seeing what I thought I was going to get. So I'll just go back to what I was looking for. Let's see, IO graph. Yeah. All right, perfect. So the graph that's displayed here is a single graph, right, with two data points. So the first one is actually it should just be all packets. Let me uncheck this here. All right, so which is shown as a line graph, right? So the second one is TCP errors, as you can see it highlighted, which is shown as a bar graph. Actually, I'll showcase that here, but there's no TCP analysis, so it'll be blank. But nonetheless, we see the line graph, right, for all packets. So so we can also see there's a minor change in the graph output because there are no or very few TCP errors, right? Now we want to take a look at the capture packet capture logs. So we can you could actually do an online review in Wireshark, which means that the packets are captured, right? So we can actually review them or save the captured packets for an offline review. Totally up to you. There's no point in captured packets, right, if they are not viewed, right? Makes sense. So you actually have to analyze the packets for various reasons, right? So like troubleshooting network issues, verifying anomalies in the network traffic, so we can actually capture the packets and have them in a file for analysis later, right? So I'm actually going to, let's see, put this out, save. So Wireshark by default, as you can see here, it saves the format as the pcapng, right? We do need to change the file type for other programs like tcpdump to be able to view the content, which is why I mentioned earlier that Wireshark could view the contents of other network or network analyzing tools like tcpdump, right, as far as viewing those files, but we want to make it, at least for whenever we're doing it and we're saving something in Wireshark, but next time someone else may want to use tcpdump, or we just want to make it as available as possible to the folks who need to analyze it. We want to make it both ways as much as we can. So even though we capture everything in Wireshark, we're going to save it as a different file type, right? So I'm actually, let me name this. Actually, let's see. Yeah, I'm fine with saving here. See, what should I save it? I'll just leave it at default because I don't want to take up too much time. Actually, you know what? Let me. Oh, it's better. Put a name again. Perfect. All right, so that's what I wanted to, that's actually where I wanted to save it, right? So now we're just going to work with logs and Windows outside of Linux. So each application and the OS generates various types of events, and these events and logs are maintained by a tool of service, right, within the OS. So we're going to take a look at the event viewer log, and naturally that would be in Windows, right? So actually take a look at the event viewer log. It'll load anything for me. All right, perfect. So now on the event viewer logs, you can see multiple different types of logs, right? We have application. Oh, there it is. We were looking for Windows. We have application, we have security, we have setup, we have system, and they hold different different reasons for what they do, right? And they're kind of self-explanatory for the most part. So let's actually take a look at the application log. Let's see what loads there for us. All right. So we see there's going to be various events that populate here that are relevant to the applications that are on the system. And the pane here, it's just waiting for it to load. Not sure why it's not. Maybe issue. Wi-Fi is good. But nonetheless, we can actually have events that are labeled as, you know what, I'll just take a look at another security. These number of events. There's quite a bit. That's probably why it's taking a while to load for us. Right, because I want us to actually see the showcase, right, for the window log, right? So we can actually take a look at these logs. But I do this in another video. So even if nothing loads for us, do have other videos. Oh, we got something perfect. Yeah, because it's not nearly as many. All right, so you can actually see the different levels, right? Warning, information. There's actually more than just that, right? I'm actually going to open this up too. And these logs here for the application services are specific to application, right? So just not going to spend too much more time. I just wanted to see it. So now we're going to take a look at enabling Windows Defender firewall logs. So let me open this one up here. If I could spell. I think I'll want it with the control panel. Yeah, I think I want that. You know, before I actually, I'll do it another way. All right, what's that? All right, perfect. So we can use the direct path, which means the C, which is the local drive that we see here, where we have installed Windows. And then alternatively, we can use the variable, which is what I did, was the percentage with the Windows directory, rather, which automatically open the Windows directory whenever it is present. So now we see the firewall doesn't exist, right? We don't see the folder for it, right? So now let's open. That's what I wanted to show that first. So now let's take a look at Windows Firewall, right? So let's take a look at advanced settings, all right? All right, so let's actually take a look at the properties, right? So let's actually customize here. One. Did it? Okay. Let's go here. All right. All right, perfect. So I'm actually going to minimize this here, right? So now I'm just going to, let me close this out too. So I'm actually going to restart, right? Guys on the other side of the restart. It should be just a few seconds. All right, so we have it restarted. So let's go ahead and open up the application I'll need here. So we're gonna, of course, run it as an administrator, a boss, right? Let's actually do that. Let's open that, right? Here, Windows, then worth here. And we'll finally go here. And what do you know? What do you know? It is open, right? So I'm just gonna hit open that. Open, sure why it's not. Oh, I see why. Darn it. It's always the small things, right? Because when I do this, right, look at what we see, right? Now we can open and look at all its glory for the firewall log. Hey, perfect. So just wanted to showcase that, right? As far as just taking a look at some Windows firewall logs and different ways to view them. I mean, a large network would normally have hundreds of network devices along with servers. So each one of them generates events, right, that need to be managed or monitored. So as the admin, you just have to perform several tasks on these events to be logged, right? So, but nonetheless, I mean, there's a ton of additional information I could go on about this as far as the log events. But nonetheless, we've reached the end of this video for incident response tools. So yeah, just for a brief recap, we actually went over quite a few things actually. Configuring system logging, tcpdump logging, capturing packets with Wireshark, working with logs in Windows, particularly firewall in this case. Now we saw how to use tcpdump, knowing key locations for logging, capturing traffic information, how to pretty much different ways to analyze it, online or offline, right? And accessing the event viewer logs as well as taking a look at or different ways to look at the Windows firewall logs as well. Thank you so much for staying to the end of this video. If you are still here, stay serious, stay curious, stay secure. I'll see you later.